Hey guys, so for today's virtual lab, we're going to take another look at chemical tests like we did last week. Only now we're going to look closer at one test and try to determine whether or not it is selective or specific. So those two terms are used to describe chemical tests, whereas a selective test is one where several compounds will get the same result. So a good example of that would be those solubility tests that we did last week. So several different compounds were soluble and then several were insoluble, and those had different elements as part of them. So while that solubility test allowed you to narrow it down when you were searching for those unknowns a little bit, it wasn't able to specifically select one of those compounds. On the other hand, a specific test will only give you the reaction with a small specific set of chemicals. So one good example of that would be when we did that reaction with where we added the silver nitrate, and that created a precipitate only if a chloride ion was present. So that test specifically searches for chloride ions. So today what we're going to do is we're going to use this reaction. It's something called an oxidative cross-coupling. You don't need to know the details about how this reaction takes place. For the nature of this lab, all you need to really know is that phenyl right here and 4-AAP, when they're mixed in the presence of some metal ion, if it's the right metal ion, they'll be able to kind of combine and merge together or oxidatively couple, and they'll form this product. And this product is a pink color. So in today's lab, if you mix your chemicals together and you see a pink color, that's a positive result. On the other hand, if the metal that you use isn't that right specific metal, no reaction will take place, or maybe some other reaction could occur where you'll get a different color, but you don't need to worry about that. We're only focusing on this reaction where the product is a pink color. Also in this reaction is this buffer solution, HEPES. You don't need to worry too much about that. But what we're going to do is we're going to mix up phenyl, 4-AAP, and then that HEPES buffer solution. And we're going to add these various metals. So these are the metals that we'll use. And then there will also be some control. So that will be a solution where instead of adding a metal, we're just going to add water. And this will show us whether or not the reaction would take place without any metal present. So I've already taken the liberty of mixing up solutions of each of these have phenyl, 4-AAP, and the buffer solution. So as you can see, before any metal is added, all of those solutions are pretty clear. And I've also set up a burette of those. Let me just quickly finish this calibration. Cool. So here is a solution of one of those mixtures without any metal added. So if I just put that in there, clicked collect, as you can see, there's no absorbance in this visible light region. So that makes sense. The solution is clear. Okay, so next what we need to do is add the metals to this solution. So I'm going to quickly pause the recording while I do that because it is very difficult to record and add at the same time. Okay, so I've just added those solutions. These last three are for later. So looking at these first 7 with potassium nitrate, it's clear. magnesium nitrate, clear. With the iron sulfate, we're getting a yellow color, which is interesting, but remember that the only positive result for this week is pink. So then nickel nitrate, clear. Here is the copper nitrate, and it is pretty pink, so that's positive. The zinc nitrate, again, is clear. And then lastly, the silver nitrate is a little pink, but not nearly so much as this guy. So after about 3 minutes is when I just started recording. It's potassium nitrate is clear, magnesium nitrate clear, iron sulfate yellow. So again, these are all negative, negative, negative. Nickel nitrate clear, so negative. The copper nitrate was pink, so positive. Zinc nitrate is clear, so negative. And then the silver nitrate kind of turned a little bit, so I'll put pink-ish, and then I'll do kind of like it's negative, but a little. This is a little ambiguous, and I'll give you a little hint. It's actually supposed to be negative, but things go kind of crazy. So the next part is I'm going to take the solution that did become pink, this copper nitrate, and I'm going to make a cuvette of it. And I will do that using this little pipette. Now our background, because you always have to do a background to calibrate in these, is actually going to be that control vial. If you remember, the control has everything except for the metal, so I added a little bit of water to it. We'll plop that in there and calibrate that again. Okay, so now I'm going to take a spectra of that copper solution, and this is at 110. So its absorbance maximum in the visible region is at around 500. Specifically, it is at 501.2 nanometers, and so that was taken at 110. So spectra, oh nope, not that guy. This is for the copper. So at 110, there was an absorbance at 501.2, I think. I will go double check that. It was 501.2, and it had an absorbance of 0.392. So that spectra was taken at 110. Now I'm going to wait just 2 minutes. So at 112, I'm going to take it again. and I will start recording then. Okay, it is now 1:12, so it's 2 minutes since the first spectra. I will store that latest run, and as you can see, the absorbance is even higher than it was before. So once more, going to that highest peak, which was at 501.2. Now the absorbance, so it's a little higher now at 500.6, but I'm going to stick with the same wavelength just to be consistent. So at 501.2, that is now 0.473. So I will add that at 112. It is now 0.473. And I'm going to wait 3 minutes and do it again. Okay, so it's just about time to take that next spectra, but I did want to show you, so that one test that gave us kind of like a maybe not positive test, I wanted to show you that it's now turned this crazy kind of purpley reddish color. So that's not a positive result that we're looking for this reaction, but something else definitely is going on, and that's, I don't know, that's pretty cool. But it's now 1:15, and so I'm going to collect again. And as you can see, the absorbance is now even higher. So at that one wavelength of 501.2, we can see that the absorbance is 0.63. So I will record that if I can find where I put the marker. There it is. So at 1:15, it was 0.63. So I'm going to record that again in 5 minutes. Okay, so it is now 1:20, so I'm going to make this final collection. And with this last collection, it's even greater in that absorbance. So as you can see, at that 501.2, the absorbance is, let me just stop and, okay, so at 501.2, the absorbance is 0.813. So we're going to stop the collection of that guy there because oh, whoops, these times are wrong. It was 1, yeah, actually no, they're not. So now at 1:20, it was, let me just double check that, 0.813. Okay, so as you can see, over time, that absorbance increased, and the reason for that is as this reaction takes place, it doesn't happen simultaneously. You don't add all these together and then bam, all of the product is made. Rather, it takes some time for these chemicals to meet in solution, and they'll form that product gradually over time. So as time went on and more of that pink solution, that pink compound built up in solution, the concentration increased, and so therefore then the absorbance of that pink compound increased. So then just returning to these other guys, this is the solution with the copper, but as you can see, most of them stayed blank. The solution mixed with the iron sulfate turned yellow, which is interesting to know, and that turned yellow pretty much right away. And then that one with that silver nitrate, it turned this real deep burgundy color, and that happened more or less gradually over time. So now 10 minutes later, since they've been mixed, it is now this, sorry, my phone started to die, so I had to hit a button. Anyway, so over about 10 minutes, it turned this burgundy color. Okay, so that's part one, where we're just observing what happens with these different metals. In part two, we're going to take 3 unknown solutions. They're right here. They're right here, so unknown A, B, and C, and we're going to add them to some new mixtures, and then we're going to try to see if we can determine what metals are in those unknown solutions. So I'm going to quickly add those unknowns, and then I will start recording again. Okay, so I just added those unknowns, and as you can see, unknowns A and B stayed pretty clear, whereas unknown C turned pink. Now, it's worth noting that these clear guys, we have no real way of knowing what they are because they could be any of these clear ones. But with this pink guy, we have a pretty strong chance of knowing that it's the one that turned pink before. So there's that. Now, with that data, you should be able to answer all of the post-lab questions and any of the those green questions within the lab handout. Once again, I will post all of this data, and I'll be available for any questions during my office hours.